Today we'll be looking at the General Maths 2022 exam and we'll be using the TI-84 to help us. We're just going to jump straight in with question 1 because obviously there's a lot of questions to get through. Feel free to jump around to only the questions that you need the help from though. Okay, so straight away from question 1 we're seeing that we have Arjun and he is going to invest for 3 years, and he's got 2 choices of where he wants to invest in, count A and count B. Account A is saying that it's a flat rate. This just means that it's a simple interest account. And then part B, or account B, is a compounding account. So if we're looking at these 2 accounts, you want to know what is the best investment. One way we can do this is to find the effective rate of each of these. Now for a simple interest account, we are going to use the EFF command from our graphics calculator, but we have to be a little bit careful. It's 2.93, and then we need to put in 1 divided by 3, where 3 is going to be the number of years. Okay, so let's go to the graphics calculator. So we want to go over to apps. We're going to go definitely a finance one. I have to scroll down a little way for this one till we find that EFF. We're going to put in 2.93, make sure you got the comma, and then 1 divided by 3 to close that off. So in this case here, we have an effective rate of 2.85%. Now I've chosen to round it to 0.85 because it does say in the question 2 decimal places. Just make sure you always are looking for something like that before you're rounding. Account B is just going to be effective, the EFF command. It's going to be 2.82, and there are 4 compounding periods in that year, each year. So it's going to be comma 4. So I'm just going to bring this one down because I don't want to write over the top. So 2.82. Keep the comma, we're going to go 4, and I'll just delete those. So it looks like it's the same answer, so it's 2.85% there. So both of them are 2.85% have as an effective rate. So I've just shown an alternative way over here in the red just to find the effective interest rate of a simple interest account, if that's something you would prefer to have a closer look at. Okay, moving down to part B. This time Arjun decides to look at a third account, and it has 3.1% compounding weekly, and he's going to be adding an extra $50 into that account every week. The balance of the account at the end we want to show 3 years is going to be the $30,100. So I've just kind of already set up our calculator input here, but it is compounding weekly, so we're going to have the PY and CY is going to be equal to 52. And because it's for 3 years, our N is going to be 3 times that 52. The interest rate we're told is 3.1%. The PV is going to be, make sure it's a negative, but we're putting in $20,000 into this account, and we're also paying $50 per week. And we want to show that the future value is approximately 30,000. So if we go apps, we go finance, we go TBM solver, we're going to have 3 times 52. We're going to have 3.1%, the negative 20,000, and then the negative 50 in here. Everything else seems fine, so we're going to alpha solve this for the future value, and we get that it's going to be $30,120. And we have 29 cents, and this is then approximately equal to the 30,100 that we needed to show. Now you can't just show the calculator input, you need to show this first. In order to get you 2 marks. Okay, so he's ready to invest, and then he sees a car and it's valued at $29,000. Arjun, obviously a pretty smart guy, is realizing that inflation is going to affect the price in 3 years' time. And so he's thinking that it's going to be an extra 2.5% per year indexed for inflation. So we need to find this indexed value. To find this, we are going to take the 29,000. We are going to times it by 1.0 1.025, and we're going to do that 3 times for 3 years. Now, if you're not sure where the 1.025 is, that's going to be 1 plus the 2.5%, and that will give us the growth rate that will affect our inflation. We do need to put that in the calculator though. So 29,000 times 1.025 to the power of 3 tells us that the car is going to be valued at around $31,229.83. I'll just fix up my equal sign. Now we're going to be using that value in the next question, because if we have to account for inflation, we need to put more money in than just the $50 that we're paying extra at this point. So when we go through to our calculator, we're still doing it for the 3 years, compounding weekly. We've still got 3.1% here. We still start with the 20,000, so it's again the negative 20,000. The payment is what we're trying to find. We're expecting it to be more than $50 though, and the future value is our index value, so it's $31,229.83, and I'll just write here it's the indexed value. Okay, I'm ready to go back and solve. So apps, finance, TVM solver, all of this is going to be the same apart from the future value. So we're going to put in the 31,229.83, and we're solving for this guy. I'd just like to zero it off first. And it looks like we're going to have to pay he's going to have to pay $56.79 per month in order to reach that indexed value. Careful though, because the question says how much extra is he going to need, so therefore we want to know how much it is above the $50. So the extra, if I can spell, is equal to 56.79 minus the $50. So it's going to be $6.79. Okay, just going down to the next page. I have pre-filled it a little bit, but we are interested here in just one factor that he has to consider when he's going to be doing this savings plan. But not only do you need the one factor, but you need to know its impact in the context of the question. So for instance, if we're looking at fluctuations in interest rates, Arjan has to consider that if interest rates go down, then he's not going to reach that goal and he has to save more money along the way. Another one might be, maybe last one I've listed there is the fees and charges. So that's one thing he's got to consider. And then its impact is going to be that if the account has fees, then again, he's going to have to pay those along the way and again needs the extra money. So anyway, just choosing one factor here, but make sure you explain its impact. So we're going to have a go at question 2 now. We've got a precedence network, and in this precedence network we're showing how we're going to renovate an aged care home, just keeping in mind that all our units are in weeks to do our tasks. So we start off by doing a forward and backward scan. Now when we're doing our forward scan, we're always looking to enter the earliest start time for each of our tasks. So if I go up to the top here, I can see that A takes 4 weeks to complete. So I'm going to put a 4 up here in the node, because that's my earliest start time for both D and E. For B takes 2 weeks. So before I can start F, I need to wait those 2 weeks for B to be completed. C is 9 weeks to complete. Now, when I go to move on, I can put my 5 over here for D, which is 4 plus 1. But down here, you can see I've got more than one task which are converging on the same node. When this happens, I have to take my largest value, and the reason for this is that because all the tasks have to be completed before the next task can begin, which in this case is task J. So I need to just go through and find my biggest number. So 4 plus 4 is 8. 3 plus 2 is going to be 5, and then we have the 9 coming in from our dummy link as well. So my on my forward scan, I need to take my largest number, and in this case we're going to put the 9 inside the node. The same deal here. Before I start K, I've got 2 tasks that are converging on the same node. In this case, I've got 7 plus 5 and 9 plus 3, both of which are giving me 12 inside. So in that case, it didn't matter. In my final node, I've already got the answer for my earliest start time. It's saying 20, and you can see that that's from the 12 plus the 8 coming in through K, because underneath I've got 19, which is my G from task G and C. So that's the forward scan done. Now we've got to go backwards, and in backwards we take our finishing node, or in this case our latest start time, and then we're going to subtract how long the task actually took. So 20 take 8 in this case is going to be 12. And I'm going to do the same down the bottom through task G as well. So task G takes 10 weeks and the whole project is 20. So 20 take 10 is going to be 10. I'm just going to put it on the outside here because we can see we've got more than one node again more than one task converging on the same node. So we have to have a little bit of special consideration for these as we work backwards. Okay, so we'll start back up in here. So I've got 12 take 7 here, which is going to be my 5. And then I'm also going to go through G, so J. So 12 take 3 for J is also going to be 9. And then as I go backwards through, I'm going to maybe come down here through my dummy link, because then I can go to that node. So I've got a 9 here. The dummy link is 0, or length 0. So 9 take 0 is 9. So I've got 2 choices to go into this node. It's my 9 or my 10. And in this case, on your backward scan, you're going to take the smallest number. And in this case, we're going to put in the 9. But we keep our 10 on the outside because that's just indicating our slack time that we have. Going through task F, I've got 9 take 3, which will give me 6. And then again, I've got 2 nodes here and I've got to take my smallest one. So 5 take 1 is going to be 4 and 9 take 4 is going to be 5. So the 4 is going to be going inside my node on that right-hand side. I only got the start one to go. So 4 take 4 is 0. So I don't need to write anything there because that's clearly going to be the smallest number. 6 take 2 is going to be 4 at task B. And then 9 take 9 is going to be a 0 as well. And that would be both my scans carried out for part A. Now it says to look at your network and decide where your critical paths are. I'll just change my color for a second. So it looks like there's 2 critical paths here. One's going to go up through A, D, down through H, and then out to K. And then it looks like you got another one as well that's going down here, through here. It also comes up through a dummy link, and then through the center, and then also out the end as well. So we do have 2. And we're going to write about those below. So we'll just say that it's A, D, H, and K. And the other one is C, J, and K as well. So they are both our critical paths. So remember our critical paths and when the early pathway network where we've got the early start time, latest start time, the same. So a company claims that allocating extra resources to task G will reduce, so we're talking task G here, will reduce the minimum completion time. Why is this incorrect? Well, let's have a look where G is on our network. So G is here, and it's not on a critical path, and that is going to be the reason, okay? Because if we allocate the extra resources there, we're not going to finish, doesn't necessarily mean we'll finish the project overall quicker. So I'm just going to say task is not on the critical path. Hang on, let me just spell that right. Critical path, it has a slack time equal to 1 week. And I say 1 week because we can see here we've got the 10 and the 9. Okay, so then it says calculate the slack time for task E. And so if we come up to task E, where are we? We're just here. We need to look at difference between these two numbers, so the earliest start time and the latest start time for task E, and we can see that we've got 5 take 4 here, which is going to equal 1 week. So that's what we're going to write down here in part D. So slack time is equal to 5 minus 4, which equals 1 week. List all the tasks that must be completed before task J can start. So J is in here. And we need to consider every single path coming in here. So you can see we've got both all A, B, and C have a path leading to J, and then E, F, E, and F, yep, and the dummy link as well. So we're going to come down here and we're going to say those A, B's, and C's that are at the start, and then E and F all need to be done before J can be started. All right, turn over the page and we've got company Y, which is an alternative model. The times completed are also given in weeks, so the same as before. We've got the forward scan, backward scan already done for us, but we do have to answer some questions about it. So it says, how long does it take to complete task P? So again, so task P is here, and we're going to look at the difference between these two, and we can see that it's going to be the latest start time to take the earliest start time, which in this case is going to be 10 take 3, and so it's going to take us 7 weeks to complete the task. How long does it take to complete task Q? So we're down with task Q down here. This time we're looking at a bit of a different idea because we're not actually on the critical path this time. So if I'm just quickly looking through this network and looking where my critical path is, I can see that I've got these. This is my critical path one. So when I was doing part A, I was quite confident that when I subtracted my earliest start time, my latest start time, my earliest start time, that'll get the time it takes to do task P. However, I can't. It's not quite the same at task Q. So this time I'm going to use the other one. So I'm going to use this 10. So I'm going to use my backward scan to go in, because the reason I can do that is because there's only one node that comes back or out of that particular node. So I'm going to say that it's going to equal to 10 take 5, which is equal to 5 weeks. So the next one is our latest start time for task S, which is up here. Now, it's the only task going into this node here. So to find the time it takes to do task S, what I'm going to do is I'm going to just say it's my 17 take 14, which is going to be 3. So if it takes 3 weeks to complete S. Now that helps me with my latest start time, because now I can take my 18 over here and I can take 3 and then to give me my 15 weeks. And so that didn't actually get put into the right hand side of the node because it wasn't the smallest number coming back through U was. So the latest start time for task S is going to be 15 weeks. So the next part of the question is they want to add extra resources because they want to have the same minimum completion time as company's X proposal. So if we go back, we're going to make sure that we reduce the time from 23, which is what it currently is, and the other one is 20. So we want to reduce it by 3 weeks to be the same. So if we're looking through our network here, what's always going to be on that critical path is R. So that's the task that I'm going to choose to reduce. And I'm going to reduce it by 3 weeks. And then it says justify our answer. Well, it's going to be because it is on the critical path, and it's always going to be on the critical task. So I'm just going to say that task R will always be on the critical path. So when this is reduced, the overall project or project time is also reduced. Also. Okay, and that's it. So the question 3 week. Okay, we're finally looking at question 3, and we're dealing with candles. Now, there's a lot of information and reading in this question, so highlighters are truly recommended. The first type is our vanilla scented candle, and now they've got a mean of 252 minutes and a standard deviation of 20. So we can kind of summarize that by saying that X is distributed normally, with 252 as our mean and then our 20 as our standard deviation. So what the company says about this is that, or claims about this I should say, is that they claim that they burn at least 238 minutes. So we're going to kind of have a look at that claim in the first question down here. So it says, what's the probability that this is actually the case? So I'm going to do a quick sketch first. I'm going to put our 252 down the middle of this distribution, and we want to know what percentage is out here, less than 238 minutes. So as a probability statement, we're going to say probably that X is less than 238, and then we're going to go to our graphics calculators to find that. So we want to go distribution, so we're going to go second function where the vase is. We're going to use a normal CDF, so number 2. I'm kind of going to play around with these numbers here. So I am going to have a lower bound of negative E99. So that's saying there is no lower bound essentially. Our upper bound is going to be that 238 minutes. We have a 252 as our mean, and then we have 20 as our standard deviation. Okay, we press enter, and then we get there that it's the 24%. Before we do that though, let's just write some stuff down. So you don't have to write this line, but I might do it for this one. So CD, it's the normal CDF, and we put in our calculators the E99. We had the 238 as our upper bound. We had 252 as our average and 20, and that just helps me if I'm going back through my paper later on to see where I could have done an error if I'm double checking everything. Okay, we'll keep 3 significant figures here, or 3 decimal places, so 0.242. And then because we're saying probability, we're going to say that's approximately equal to 24.2%. So 24.2% actually don't burn more than 238 minutes on average. Let me just fix this up, looks a bit messy. Okay, next question. On one day, okay, so this is just one particular day where their company makes 5,000 of these candles, and this says, well, how many expected to have a burning time less than the 238 minutes? So the expected value is going to be just equal to that 5,000 times by the 0.242. Oh, no, sorry, 5,000. And we're going to get 1,210 candles. Don't forget that the number of candles has to be a whole number or an integer. Must be an integer solution. So if you did have decimal points in your answer, make sure you round for those ones. Okay, moving on. The company expects to receive complaints from customers who have purchased candles with the shortest 10% of burning times. Okay, so again, just a quick sketch to make sure we get the right tails here. So our average is going to be the 252, and we're after the shortest one. So it's the people that are not getting much life out of their candles that are going to be complaining, and that's going to be 10% in the tail, and we want to find this missing K value. So our probability statement is probably that x, which is our random variable, is less than k, and that's going to equal the 10%. So we'll keep it at 0.1. Now this time when we go to our graphics calculator, we are going to go second function distribution, but we want to go into the inverse norm, so down to number 3. And we're going to have an area of 0.1. The mean is the 252. Standard deviation was 20, I think. And we've got that left tail. And we get 226.37 minutes. Again, you don't need this line, but I'm just going to put it in anyway. So 0.1, 252, we had 20, then we use the left tail. So we get 226.37 minutes. And then this time around, we're going to keep a couple of decimal places. We're talking time. So it's more of a continuous variable. Last time when we counted the number of candles, we had that integer solution. Okay, so next page is probably another candle, which it does look like it is. So we're doing row-centered candles this time. We have, with these ones, we've got a mean of 245 and a standard deviation of 25. So we can summarize that by saying that x is distributed normally with the 245 and then the 25 squared. Oh, don't need to do that. Okay, so this time the company claims that a greater proportion of rose-scented candles will burn longer than 300 meters, so longer in comparison. So then we're going back and comparing it to the vanilla-scented candle. So we need to do two calculations here. I'm probably going to split my page, my working space, in half. So on one side, I'll do vanilla, and I'll calculate the probability. On the other side, I'll do my rows. And I'm going to just do, because I like to do my quick sketches, one for each. So my vanilla had the mean of 252. We're interested in claims larger than, oops, how am I going to put that in? Just give me a sec. So 300. And then on this side, that's not a very good one. This side it got, again, another distribution. We've got the 245, and we're still interested in the numbers more than, or the percentage, so more than 300. Okay, so going to the calculations, we are interested in the probability that x is greater than 300. So we're going into distributions again. We're going down to the CDF, and we're going to have our lower bound as the 300. Our upper bound is going to be that E99, so a super big number. 252 was our mean, and then this time we had a standard deviation of 20 for the vanilla. And we get that number there. So again, up to you if you think you can fit this in. I will see how I go. I'm going to say normal CDF. We had 300. We had E99. 252 might just fit. Actually, no, it won't. And then 20. And then my answer that I got from that is going to be 0.0082. And we're going to do the same thing for our rows and compare and see which one is bigger. Okay, so down here, back into our distribution, we're going to go into our normal CDF. The lower bound is going to be 3, so it stays the same. We're just going to change the means to be 245 and 25. Okay, and this time we get 0.0139. So we're going to try to write that down again if we can fit. So probably that x is more than 300. We'll do a normal CDF. We'll fit our 300, hopefully. The E99, the 245 was our average, and then the 25. And then our answer is going to be 0.0139. This is telling me that my claim is correct. And the reason is since the rose percentage is more than the vanilla. Okay, now this is when we get a third candle coming in, and this time we have a lavender scented candle, and we've got a mean of 245, standard deviation of 20. So I might write here, X is distributed normally. We've got our 245 and we've got our 20. Okay, so we need to pick which one is which, essentially. Now, we know that we have two that have an average of 245 minutes. We've got the rose-scented candles as well as our new ones, which are the lavender. So at 245, I'm expecting to have two means, or two peaks, sorry, at that value. So I've got to choose between B and A. One of them has a bigger standard deviation than the other. So this one here that's more spread out, okay, has a larger standard deviation. So I'm going to go back. I can see that my one here, for the lavender, has a 20 standard deviation, whereas my rose one, I said earlier, had 25. So this one here has a standard deviation that is bigger, which equals 25. This one here has a standard deviation which is smaller, which equals the 20. So I'm happy that A is going to be the rose from at the top of the page, and then this one, the taller one here, which is just the dotted line, is going to be my lavender, which has a standard deviation that is 20, which means that C should have a average of 252, which was going to be the vanilla right from the start. Oh, no, not standard deviation. We had a mean. That was what was the same. So the mean is equal to 252, and that's why that one was different to the other two in the start. Okay, so we filled in our boxes to get us our 2 marks for part DI. Then it's asking us to have a little bit of a think, and it's saying explain why the maximum height of the probability distribution of A is lower. Okay, so why does the rose have a lower maximum height than B and C when considering the properties of the probability distribution curve? Okay, so the key word here is thinking about what that probability distribution curve is and what the properties of the probability distribution curve are. So we're going to say something like this. So we're going to say that A, which is my rose, okay, has a larger standard deviation than B, which is the lavender, and C, because we had to talk about both, which is the vanilla, which means a larger spread of data. Now for our second mark, we're going to say since the area under the curve must equal 1, because it is a probability, the height has to be lower. So it has a larger standard deviation than the others, so a larger spread of the data, and because of that, the curve still has to equal 1 to the curve, so it has to be lower. And that's it.